All right, so the first thing I want to do today is to talk about the conditions under which markets are going to be efficient. So just to remind you what we're talking about when we say that markets are efficient, we have this particular idea called Pareto efficiency, right? And essentially what we mean by Pareto efficiency is that some outcome is Pareto efficient or Pareto optimal if there's no alternative to that outcome that would make one person better off without making somebody else worse off. In other words, some outcome is Pareto efficient or Pareto optimal if there's nothing else that's better from everybody's perspective, right? So we'll say an outcome is Pareto efficient if no alternative makes someone better off, without making someone else worse off. And our first welfare theorem, which we're going to be talking about in this video, is essentially going to say that markets are Pareto efficient under three conditions. So first of all, we need price taking. Which is essentially to say that no individual can have any effect on the price of goods. Second, we need no externalities. My choices can't positively or negatively affect other people. And then lastly, we need no information asymmetry, or no private information. In other words, buyers and sellers have to have the same amount of information about whatever's being bought and sold. So the way that I'm going to go through this theorem is I'm going to start by going more clearly over the first part of this. Why it is that competitive equilibria are Pareto efficient, and then we're going to talk about why we need each of these three assumptions and what happens when each of these three assumptions is violated. So the way that we've thought about market efficiency is to think about three different tasks that markets have to accomplish. We've said that in order to be overall efficient, we need markets to be efficient in all three of these tasks. So what are the tasks? Well, the first thing is what we've called input efficiency, right? The task of figuring out how to allocate resources, land, labor, capital, etc., to the production of different types of goods, right? The second task we've thought about, which we've thought about with exchange or allocative efficiency, is the task of distributing the output of your economy, right, the goods that we produce, to different individuals. And then the last task that we've thought about, which connects these two tasks, is what we've called output efficiency, which is deciding how much output, how much of different types of output we'll produce out of all of the options that are feasible, given our technology and given our resources. So what I want to do is walk through for each of these three tasks what we need in order for that task to be done efficiently and why it'll be done efficiently in a competitive market. So let's start with input efficiency. The idea here, right, we thought about this by drawing an Edgeworth box, right, to think about how we're going to allocate all of our resources between two different industries, the strawberry industry and the avocado industry. Right? What are our resources? We said we've got land, and we've got labor and we've got capital, which we call land. Should really get that one straight. So how did we say that we'll be allocating labor and capital efficiently between these two markets? Well, we said that we'll have efficient allocations of resources when there's no alternative that would produce more strawberries without giving up some avocados, or produce more avocados without giving up some strawberries. And that has to be true because if we could get more avocados for free, we can hand those avocados to somebody, make them better off, and therefore make someone better off without making anyone else worse off. So what this looks like graphically, right, is that if we draw our isoquants, showing all of the combinations of labor and capital that can produce specific amounts of avocados and strawberries, we'll say that we are input efficient at all of the combinations where our isoquants just touch in one point, right? So that all of the combinations from this point, right, that produce more avocados would produce fewer strawberries and vice versa. If we were somewhere like here, there'd be overlap between our isoquants, right? We can move somewhere in this direction and get more of everything, so we wouldn't be input efficient. We've connected all of these points. Call this our production contract curve. And what we've said we needed in order to be on our production contract curve, as we can see here, is for our marginal rate of technical substitution in each industry to be equal. Right? In other words, the relative productivity of capital to labor has to be the same producing avocados as producing strawberries. We can see why that's necessary graphically, right? That's what we need in order for the isoquants to just touch once. But also intuitively, if let's say labor was relatively more productive in avocados than in strawberries relative to capital, right, then we could get more avocados and more strawberries by moving some workers to the avocado industry and moving some capital to the strawberry industry. Cool. So what this means is that in order to be efficient, we need that the MRTS in avocados right, is going to equal the MRTS in strawberries. Cool. So why does this happen in a competitive equilibrium? The reason is because each of the industries is going to be minimizing their costs, right? And if we think about the avocado industry, in order to minimize your costs, you think about all the combinations of labor and capital that produce the right amount of output for you. Right? Produce the amount of output you want to produce. And you say which one is cheaper given some wage rate and given some rental rate. Right? Given that I've got costs given by W over R, I'm going to have to end up at some point like this, right? In other words, I'm going to find where my MRTS is equal to my cost ratio, W over R. So because this is happening in the avocado industry and in the strawberry industry, we'll say MRTS A equals W over R equals MRTS S. Therefore, the avocado MRTS equals the strawberry MRTS. Right? Graphically, we can just stick a little line like this through each of these with a slope of W over R. Awesome. Okay, so this is input efficiency. How about exchange efficiency? What does it take in order to allocate goods in the most efficient way possible, right, in a Pareto efficient way between two individuals? We thought about this by drawing an edgeworth box as well. Right? In this case, the two sides of the box were two people, right? We said you and Maud. And the stuff that you're allocating is outputs, right? So avocados and strawberries. Cool. And what did we need in order to be Pareto efficient, in order to be exchange and allocatively efficient? We need to be at an allocation where there's no alternative that would be preferred to both of you, right? So that if the two of you were offered a chance to trade some of your stuff, you would have no potential gains from trade. When's this going to happen? It's going to happen when there's no overlap between your indifference curves and Maud's indifference curves. Right, when we have some picture like this. Each of these positions here is exchange efficient because everything that's preferable to you is worse for Maud and vice versa, right? There's no alternative that would make you both better off. If we were somewhere like here, we wouldn't be exchange efficient because we could move over here and make you much happier without changing Maud's happiness at all, or down here, make Maud much happier without changing your happiness at all. And again, we drew some curve through all these points. Right, we call this the contract curve. And we said that in order to be on our contract curve, as we can see graphically, your marginal rate of substitution has to be equal to Maud's marginal rate of substitution. Right, so we say MRSY for avocados and strawberries has to equal Maud's MRS. Right, and again, intuitively, if we think about what this means, it means that you're willing to trade avocado or strawberries for avocados at the same rate that Maud's willing to trade strawberries for avocados, which means that there's no way for both of you to trade and get something better, right? Come to a mutual benefit. So why is this going to be true in a competitive market? Essentially because in a competitive market, you guys are going to have some budget constraint, right? If we had an endowment, like say here, we would draw a budget constraint like this, where there'd be some price ratio, PA over PS, right? Each of you would solve a standard consumer optimization problem where you have a budget constraint with slope PA over PS, right? And you're going to choose your best option. So your best option is going to look something like this, where your MRS has to equal PA over PS. So that means that your MRS is going to equal PA over PS, right? Your MRS is going to equal the price ratio. And Maud's MRS is going to equal the price ratio. And that means that your MRS has to equal Maud's MRS. Great. So all that leaves is the link between these two problems, which is the problem of how much of each output to produce. We thought about this by thinking about all of the possibilities first, right? All of the combinations of strawberries and avocados that we could afford to produce. Right, and saying that each point on our production contract curve, right, let's say points 1, 2, 3, and 4, correspond to some combination of avocados and strawberries that we can produce. Let's say 1, 2, 3, and 4. And we said that our right choice, right, so this represents all of our possible choices, our production possibilities frontier. Our right choice is the one that's most valuable to our consumers, which means essentially that if I drew an indifference curve for a consumer, it would touch my production possibilities frontier in just one place. And as long as we have exchange efficiency, right, all of our consumers will have the same MRS at the output that's actually produced because it'll get allocated efficiently. So what we need in order to have efficient production of outputs is for our MRT, the slope of our production possibilities curve, to equal our MRSs, right? So we need our marginal rate of transformation in terms of avocados and strawberries to equal MRSs in terms of avocados and strawberries. Why is this going to happen in a competitive equilibrium? Well, we said that our MRT is going to be the ratio of the marginal product of labor in strawberries to avocados, right? And we said that our producers, when they're maximizing profit, are going to produce where price equals marginal cost, which is going to mean that price is going to have to equal W over MPL, right, for any particular good. So if we thought about avocados, right, the price of an avocado has to equal W over MPLA, which means that our MRT is going to be equal to W over MPLA divided by W over MPLS, which is going to equal PA over PS, right? So the argument is essentially, when firms are profit maximizing, they're going to produce output until the marginal cost of an avocado equals the price of an avocado, the marginal cost of a strawberry equals the price of a strawberry. We can think about our production possibilities frontier as being the ratio of those marginal costs. So in a competitive equilibrium, we'll end up with our price ratio representing the ratio of marginal costs and equaling to the relative value of the two goods for producers, right? So we're going to say MRT is going to equal PA over PS is going to equal MRS. In other words, our consumer prices are going to set the marginal cost of production equal to the marginal value to consumers. Okay, so this is a lot of complicated graphs and equations, right? There's a lot to absorb in these pictures. But what we're really seeing here is the same magic trick being repeated in each of these problems. What that magic trick is that in each of these graphs, in each of these jobs that the economy does, each individual is doing what's best for them, not only without caring about what's best for everyone else, but without knowing what's best for everyone else. If we think about what a strawberry producer knows when they're deciding how to use labor and capital, they know their own production function, and they know the wages and rental rates of labor and capital. They don't know anything about what's going on in the avocado industry, right? They don't know if avocado production is relatively labor intensive or relatively capital intensive. And the exact same thing is true of the avocado growers, right? They know their own production technology, and they know the prices they face, but they don't know anything about the strawberry growers. So how do they end up working out a mutually beneficial exchange, right? An efficient exchange? They're doing it because the prices, right, the wage of workers relative to the rental rate of land, are going to transmit information from one industry to the other. What I mean by that is, right, when avocados need relatively more labor, they're going to bid up the wages of workers. And then the strawberry industry, right, firms in the strawberry industry are going to say, oh shoot, workers are so expensive now, I should shift over towards capital. Right? So the prices contain all of the information about the way that each individual firm's choices affect other firms, right? How valuable the inputs that they're using are to other firms, so that each firm only has to think about their own interests. Same thing's happening here, right? When you walk into the grocery store, you don't have to know whether there was a boll weevil that went after the avocados this year. You don't have to know whether the rain was too much or too little for strawberries. All you know is how much you want to eat an avocado versus a strawberry, and how much avocados and strawberries cost you. And so you're going to make your purchasing decisions until your MRS equals the price ratio, right? By doing that, you and collectively all the people like you are going to influence the price of avocados and strawberries to tell firms about how valuable these inputs are. Likewise, right? The firms making avocados and strawberries, if we think about a competitive industry, an avocado grower or a strawberry grower might not really know why or how much people like their product. What they know is how much they can sell it for. Right? They know their costs of production, they know the price, and that's enough for them to be able to make their decision. So again, right, prices are conveying information from producers to consumers and vice versa. And so essentially what's happening, right, is that as each individual decides to buy and sell, their decisions are making small changes to overall prices that propagate back and forth through the entire economic system and essentially share that individual's capabilities, their preferences, their needs with other actors in society through their effect on those prices. And so what a market economy allows us to do, right, is have ultimate outcomes that make sense from all these different perspectives without anyone having to know the private information of anyone else. So what this means is if we wanted to replace markets with something, right, if we wanted to think about other ways of achieving input efficiency, output efficiency, or exchange efficiency, we would need to think about what other mechanism we could use other than prices that could convey all of that rich information that is held by individuals and institutions to whatever organizing force is trying to make economic decisions. Right? And likewise, if we think about trying to help people by changing prices, right? If we thought about things like imposing minimum wages or trying to subsidize the consumption of relatively low-income people, one of the things, those might be very good policies, as we'll talk about in a moment, right? But one of the things that we'll worry about, one of the things that we'll think about, is how changing those prices is going to affect the information conveyed in those prices, and as a result, how that's going to distort economic behavior and incentives. Okay, cool. So this is essentially the positive story, right? This is the reason that markets work, embedded in the first welfare theorem. In the next video, we're going to talk about the other side, right? These three assumptions that we need, and what they say about why markets might not work.